Okay, so in this video clip I'm going to continue on from the previous session where I investigated using ggplots the effect of increasing engine size and fuel efficiency. And I'm going to open up a new instance of RStudio, but because in the last session I was using the dataset MPG and I was implementing a code that I'd taken from chapter 3, which related to visualization, chapter 3 of, let's just go back to this web link so that it's easy to track what I've been doing, right? In fact, it's R for data science. So if I just load that in, paste, go, it brings me to R for data science, and we're on chapter 3, and there's a set of R instructions from the ggplot package in R that we can implement in RStudio, and it sets out ways that we can identify, relate two variables to each other, and then break apart different categories within that data, which in many instances can solve some outlier puzzles that occasionally will appear in the data. So what we had done before was we had the package is already installed. I have to invoke the library, so it's available. Perhaps I'll clear out the global environment, so there's no data here. If I run MPG and then data MPG and structure, we can see that the data is now available and we can view it here in terms of the relational database. I go back to the R script, and if I run, I'll pass through the comments, and we can just in a whirlwind way pass through the graphs. So I've graphed the engine size relative to highway efficiency. We can explore that more if we introduce color using the ggplot syntax. And by adding color here to our code, for each class of vehicle, we can identify different color. Now, in addition to that, right, we can use other optics like size, and sometimes that makes sense. Although here it's not adding much in terms of overall visibility or transparency, but it is a possibility, and we can improve in that perhaps if we were writing a report, a business report, and the publication was going to be in black and white. Then we can go through different hues of black to grey, which may be useful. Not every publication can be done in color. Sometimes there's cost implications. We can introduce shapes. Maybe that's a bit better. We are limited though by the number of shapes available, and that might be a constraining factor. But again, we can kind of see that in different types of publication, maybe black and white type publication, this is more meaningful to use these type of symbols. We don't have a specific shape for SUV here, and that's a restriction here in terms of the number of shapes that are available. Okay, we can do blue, and that doesn't add much except, okay, everything is blue. And we can develop our data in a way that we break apart the different classes, and so produce a graph in a kind of grid system where each class of vehicle, so the two-seater vehicle, the compact vehicle, the mid-size minivan, all the way up to SUV, get a separate graph. And again, we can, when we look at these in their own class categorization, the overall trend would appear to be higher engine size, the lower the efficiency. Now that's not compelling. Here it looks a bit more compelling. Here I'm convinced with the mid-size vehicle, as we increase the engine size, fuel efficiency drops. Minivan, something similar. For some compact range, okay, we can see it's a negative relationship and so on. And that's useful that we can break the data apart like that. Okay. We could also add different types of color here. That might, again, if we can publish in color, it makes sense to make it more meaningful and use the available aesthetics that are in the ggplot. Again, I think it does help a little bit in this instance. We can also have different types of categorization based on the data that we have available. So for instance, we had 4-liter engine, 5-liter engine, 6-liter engine, 8-liter engine, and then we had 4-wheel drive, front-wheel drive, rear-wheel drive, and then in each of these instances where we had 4-cylinder engine for the 4-wheel drive, we can map out the relationship between the fuel efficiency and the fuel efficiency and the engine size. Again, looks negative, and here somewhat negative, maybe less compelling here. Would appear here that's fairly sharp for the 4-cylinder engine with the front-wheel drive, that the fuel efficiency deteriorates quite fast as we increase the size of the engine. Okay, so these are kind of additional or alternative optics that we can use to pivot or to view through different prisms the underlying data. Everything provides us with additional opportunities to view and to make our analysis a little bit deeper. What are the underlying trends, okay? And we can do that in color, and then we can revert back to what we started with. And again, you can see this is a useful diagram where we have all 234 observations with the different columns of. So if we go back to our script and come to, okay, so if we run that set of code here, it is our basic starter diagram here, right? But we may wish to look at, instead of points, maybe we want to observe a trend. Can we put a trend here through the data that we observe? And let's try that. And if we run the geometric or the geometry smooth, okay, with the mapping and on the x-axis, this is our x-axis, the horizontal axis is the engine size, the vertical axis is the fuel efficiency, we can observe a trend and then a confidence interval around the trend. So if we went back, we might note that there's probably less variation here, higher variation, more uncertainty here. When we try to interrogate our data, we could say, okay, there seems to be some kind of strong relationship here between the fuel efficiency, this engine size, fuel efficiency, and it kind of breaks down here. Okay, so we can do similar again, but break it down for the different class of drive. So we have the 4-wheel drive, we have the front-wheel drive to rear-wheel drive, and so we've, if you like, distilled our data into 3 data sets. Okay, so we broke apart our overall global data, and we're assigning a line type to each drive. Again, we can, if we run the next snippet of code, what have we done? We have changed, we've grouped it, right? So we have, for each group now, we have designated the drive as opposed to the line type. And then we can change for each drive, we can designate as a different color. So we have the green, we have the red, and we have the blue. And keep in mind that this was the 4-wheel drive, the front wheel drive, and then the rear wheel drive. Okay, and we can smooth, again, the geoplots point and then smooth combined together, and we can produce a graph where we combine. Okay, so if we want, we invoke the ggplots, it pulls in the data for MPG. We want a point geometry using the XY plot, so that is static. So each of the 234 data points are arranged as dots, XY combinations, and then the geometry smooth geometry, right, where we use again XY plot. It's not a scatter graph, but in this instance, right, we saying, look, let's set up the observations as a trend line, okay, with a confidence interval around the trend line. We can then go on and add color, right, to the different data points. Again, that's useful because, again, this is quite puzzling, why the improvement in the fuel efficiency as we increase the engine size here. It comes down to the presence of the two-seaters. So these two-seaters are probably smaller type vehicle, and they can squeeze out an extra bit of fuel efficiency despite the higher engine size. So they're probably sports vehicles. Okay, another type of chart that we like to look at are box plots, and they can be quite revealing. Again, the box plot in ggplot follow in line with typical box plots. We have the first quartile, the third quartile, the median, and then we have the outliers. Okay, so we've the median, the first quartile, the third quartile, and 1.5 times the difference between the first and the third quartile, and then values or outliers outside those ranges. So the biggest variation we have in terms of fuel efficiency probably coming with the SUVs and the compact vehicles. Some of the compact vehicles, generally they have high fuel efficiency, but in particular these ones we can see there's some real outliers here in terms of fuel efficiency, and in the subcompact as well, higher fuel efficiency, again with some real star performance in terms of fuel efficiency. We can run the graph in such a way that we flip, so the coordinates flip, and instead of having the fuel efficiency on the vertical axis, we now have it on the horizontal axis, and then we do that for each class of vehicle. So again, it's just another perspective to view the data, and it offers perhaps, again, in terms of writing reports, maybe you do need a more rectangular, wider frame for some, when you're producing a report, there may be an opportunity to create long, wider graphs as opposed to narrow, long graphs. Okay, so these are interesting graphs. We could also go back into our for data science, go back to the HTML reference. We were on chapter 3. If we go down to chapter 28, so this is quite a substantial document, and graphics for communication. And again, if you're a salesperson or car salesperson, one of the things you might like to communicate is fuel efficiency to clients. You might use a database like this. So we, and this invokes the deplyr package, which is used for data manipulation. So if I copied that sequence of code, right, and I go back to RStudio, and we'll just load in here at the end. So I'll make some space here, right, and paste the code in, the R code in. And again, we are invoking, in this case, deplyr. Okay, so let's run best in class, run, and then do the plot. We find that we can add annotation, which can be very useful. So we want to demonstrate, look, some cars are very fuel efficient, right? And the beetle, for instance,